Hello, am I audible to all? Please, someone confirm from online.
Yes, sir. It's audible.
Okay, okay, fine. So, yeah, uh, did you guys receive the code link? It is posted on same GitHub repo. Can you check?
No, yesterday you posted one Google collab, no, sir. We went through there.
Sorry, you are not audible.
Yes, sir, we visited that link.
Okay, okay. So let's begin the today's session.
Okay.
Yeah. So, in the today's session, we are going to cover the CNN model and classification. Further, we will explore a part of clustering algorithms. Okay. So, basic tentative outline of the today's session is first we will understand classification. We will build a CNN model. Uh, we are not going to go too much complex, simple CNN model so that we can learn how to build it from scratch. And yeah, we are going to explore some model parameters. Further, as we learn in today's lecture, there are lots of CNN architectures which already develop on complex data. So we are going to use them via transfer learning, and in the later part we will go through clustering. So let's begin. Before that, let's explore about gradient descent algorithm. So here, what we do, we generate a number z. There is a variable z which is incrementing with zero point zero 0.01 value, and we are going through 1,000 iterations. So if we go zero point zero 0.01 into 1,000, so it will come to approx plus 10. And let's set a parameter number is equals to 4. I will tell you why we set. Okay, so import a matplotlib library, which is essential for some basic visualization. So here I have defined a function square of z, where it returns z square, and we are going to plot it. So we already defined z here equal to -5. So within the range -5 to +5, we got a curve of x square, basically, yeah, z square. And our number which we set 4, we get its square here, 4 comma 16. Then what we do, we are gradually decreasing number by zero point 0.3. Can you see? So earlier it was 4 comma 16 point, and later it come to 3.7, and the square of 3.7 is 13.69. So if we run, we are getting the points. Gradually it is decreasing by zero point 0.3. So I want to show the gradient of square, like derivatives of x square function is 2x. So what we do in gradient descent algorithm, we try to optimize the weights. So we calculate its gradient, nothing but its their derivatives, and we get the minimum and minimum value, which gives us optimistic results. So in this figure, you can see graph comes to 1.24 and further its square. Oh, that's how the basic gradient descent algorithm works. So we will now come to our CNN classification problem. What we are going to do is we are going to work on MNIST dataset. First, we will import some libraries. We are using PyTorch as a platform. Like there are TensorFlow and PyTorch libraries. So these uh, like PyTorch is new, kind of relatively new, and it's more advanced. It's more comfortable also. So we are going through PyTorch. First, we import our dataset from Torch Vision dataset. If we see, uh, yeah, this is official documentation of PyTorch. Yeah. So they have some built-in dataset. So for image classification, these are quite useful dataset. You can practice. I also provide the link in the text markdown also. So let's download our dataset. It's downloading. It's not too large. It is easy to download. So further, we create a data loader. What it does, basically, in a data set there are lots of images, so loads in a it loads images batch wise to our data loader. So for train loader and test loader, we created individual for train data and test data. Basically, I want to make a note here. We don't include shuffling for testing data. If you see parameter shuffle in the training data, it is necessary to make it more generalized model. But in testing data, if you do or not do, it is going to same. We are going to predict the labels. So no necessary. Okay. So here I define a CNN, simple CNN neural network module. In the first, I added first convolutional layer with input size 32 and kernel size 3, padding 1, and stride by default is 1. If you see 32,64, this is input and output. Uh, in the second layer also, same. I added a convolutional layer followed by pooling. So we have used max pool feature here with kernel size 2 and stride 2. Kernel is basically our filter which extract the features from the images. And again, I don't set a padding. Then in the last, I added fully connected linear layer, and follow, yes, in the last also, after that fully connected layer with 10. So here 10 is nothing but these are going to be your output classes. Yeah. In the forward class, I have added a pool ReLU function. Basically, what after each convolutional layer, it is followed by ReLU activation function. Do you guys know activation functions? Anyone have any ideas? How many of you know? Okay, only one. Two. Right. Okay, so what basically what it does, ReLU function, when the input comes in a neuron, that activation function give process the output. Okay, yeah, yeah. You can explore this CNN model by adding few more layers and increasing the complexity. I print here our basic CNN model. This is two connected layers, one pooling layer and two fully connected layers. Here criterion we have set for cross entropy loss, as we are going to perform classification and optimizer. Yesterday we learn about optimizer, and as Chatterjee sir said, Adam is the most used right now. There are different optimizers also, you can give a try. uh, Here I have mentioned some like gradient descent, stochastic gradient descent, mini batch gradient descent, and all. You can explore these here. I have mentioned the link of official. Okay, this is not that link. Fine. Here you can see there are different kinds of optimizers. Here algorithms are mentioned. AdamX is there, AdamW is there, sparse Adam. I think you should try these as well, and matlab, you have to experiment. Choosing parameters is really a hectic task in deep learning model, but yeah, you have to do it. It's crucial. Again, coming to the training part. So what we have did is, first we define a train class which takes, you see there are few values like model, train loader, criterion, optimizer, epochs. So what all are these? These are parameters of our training class. Okay, so initially we created an empty list which stores training lost. Further, this is training accuracy and testing accuracy. We set our epochs run, and yeah, these epochs parameter come from here. Here I select 5 epochs right now. You can explore with 10, 25, 50, but right now I have set to 5 because we have limited time. In the model.train, what here are some function optimizer dot zero grad. So what it does, I have created a note here. So basically, this zero dot grad function is used to prevent loss for accumulating new gradient values from previous ones. Okay, let's. Okay, oh sorry, I didn't run the cell. It took time to train a model, but yeah. So we learn CNN model, right? Architecture in the today's session. How it works, we know. Are you guys able to run it? No? Code is not working. Let me see. I hope you guys are following. Okay, so yeah, first epoch is completed. You can see loss here and training accuracy. We also get testing accuracy here. Basically, training is 94.8 and testing is 98. Really? Okay, fine. Let the model get run. So here I have added some visualization of training and testing accuracy curves. Basically, this is a matplotlib function. I used to visualize this. Uh, Again, if you stuck anywhere, just Google the error. There is no escape from it. You have to Google it and you have to learn from this now. Yeah. Okay. So these are 5 epochs and training loss is here. You can see our main aim is to minimize the loss. And within 5 epochs, we almost cover from 0.18 to 0.002 below 0.002. And in the right side graph, there is a curve, one presenting training accuracy and one is showing testing accuracy. So as you increase the number of epochs, you should try this. I took here 5 only. You can go to 10, 100, 20, 50 also. Uh, Reason only I took 5 here is it took time to train the model. So, okay, this is our model summary. Basically, what it does, it shows the input and output of our model. First one, as we see, uh, output shape is 28 comma 28, and in the first layer you get 320 parameters. In the pooling layer there is no parameter added because we just getting the maximum value from the features, so we are not parametering a function. So sorry. Hmm. Yes, yes. No, no, these are not minus four values. So basically, this is function. Our input size is 28 comma 28 comma 1. So what is this is 28 or 28. There are height and width of the image pixel. One is the we have grayscale image. That's why it's one. If it's an RGB image, it will be 3. And yeah, so that is it. We have used kernel size 3 cross 3, I guess. Yeah. Hmm. As we see, total parameters are 420,000 and 642. We create a model of 2 layers of convolution and 2 fully connected. Within 4 5 layers, it comes to 420 parameters. So you guys, can you imagine that latest model GPT-4? It OpenAI trains on 1.76 trillion parameters. So as you increase the complexity, it took a lot of time to train, and it, yeah, lots of computation power also. So here I print some weight matrix of our features. You can see all these are weights, and this is 3 cross 3 our kernels. So in the this is layer name, basically first convolutional layer and its weight tensor. uh, yeah, from here it's second convolution layer. In the fully connected layer, all weights are get in linear matrix. Earlier it was 3 cross 3, but further it converts to n cross 1. Okay. Our model is still training here with 4 epochs are completed. Let's explore. I have some twist for you guys. These are a visualization of our features. Basically, what first layer extract the features from images. So these are basic visualization. You won't see clearly because itself our input image size is 28 cross 28, itself very small. And yeah, so these are basic pixel values. So I want you to explore the regularization techniques. What happens if you implement these techniques on the CNN, and why these are essential. So basically, when you see there are lots of complex CNN architectures there. So what it does, they while we train our model, it picks some biased. They become biased while training. So to avoid that biasness, to avoid the overfitting, we used regularization techniques in CNN. So main motto is prevent overfitting. What overfitting does, basically we get good training accuracy, but we when we test on unseen data, our testing accuracy falls down. So to prevent this, there are few regularization techniques. One is dropout, one is L1 regularization, L2 regularization. Basically, this is to improve the generalization and robustness of model. We learn the importance of generalization model in the today's lecture by Dr. Indu, ma'am. Yeah. So what I want is you guys should perform this, and uh, I will tell you in brief. We have developed very simple CNN architecture here. So you will see how adversely our accuracies are going to affect by this regularization technique dropout, because we have added only 2 layers and we are dropping 50% of them. So our model is performed to worst. You should let me know what are the accuracies. Okay, I have mentioned here. Accuracies are below 10, below 5, I can see. So similar story with L1 regularization technique. Here, what we have did is L1, we added L1 strength parameter and we set the L1 penalty. You guys really explore these techniques. We see L1 regularization technique is at penalty to direct it proportional to direct weights. We set it coefficient. And what L2 does, it is basically function. Yeah, it adds penalty to the loss function based on squared values of the model parameters. Why squared values? Because if coefficient value or weight value is negative, then it balance off while summation. So to avoid this, we did square. And this is how this technique works. So coming to the transfer learning, in this section, we have explore ResNet 50 structure. If you guys see, let's train this again. Import some required modules. Basically, this shows we import MNIST and CFAR10. You guys should try. Here I have experimented with MNIST dataset, but you can explore CFAR10 dataset, which also have 10 classes and different images of each class. This is basic neural network modules, neural net optimizer. Myplotlib is used to plot the graphs. Transform we have used here because what happens is ResNet 50. What are these popular architectures are? So they have input of three channel RGB image input, but we are working on grayscale image dataset. So we have to transform the image data to number of output channels equal to 3, and we normalize their values with mean and standard to zero point 0.5. Similar story with test data set also. Then we perform custom ResNet module. So what we have did is this. You guys see torch.hub.load. I will show you this torch.hub. Basically, it is hub of all models, mm, all pre-trained complex CNN architectures. We can say this is its official documentation. You guys can explore. Okay. So we have printed our ResNet architecture here. If you guys observe, here is the input and kernel size on the first layer is 7 cross 7. Implemented some stride. What stride is, while convolving the image, input image, we skip with 2 rows, and we have added a padding of 3. Further, basic batch normalization. Then we have implemented a ReLU activation function. Uh, ReLU is not the only one activation function. There are different activation function also, like softmax. Uh, TANH is there, sigmoid, we can say. So you guys must explore this section of activation function. If you guys, yeah, here you can see linear function, sigmoid function, softmax, ReLU. You should explore these, how it works. Okay. Mm, yeah. So this is bottleneck architecture. This is second layer of ResNet 50. No, these are blocks. Okay. In the last, we have used average pooling, like in ResNet 50 architecture, and these are in features. And out features basically our number of classes as we set to 10. We fine tune this according to our data set. If you guys are working on some other problem like brain tumor detection, so I can show you that data set also. It have 224 by 224 images, and yeah, here the data set is. You can get it on Kaggle. You can download from here. Yeah, four classes are there. Each classes contains 300 images of brain MRI images, and one is glioma, one is meningioma, one is no tumor, one is pituitary. So if you guys use this data set, you have to change this parameter number of classes last from 10 to 4 and customize the ResNet 50 model, fine tune it, and then run it. So this is the structure of ResNet 50 model with output shape and parameters are mentioned in the side column, right side column. So if you explore and sum it all, it goes to millions of parameters. ResNet version has different models. Like today's session, Kamlesh sir taught us about ResNet 152, but it is very heavy architecture. That's why we have used its ResNet 50 layer version. So itself, it has 47 million parameters. So again, it is going to be heavy for computation. What we are doing is we are enabling gradient computation in the last layer. So what it does, we are using the ResNet 50 model weights itself, but we are fine tuning that model for our particular task, which is right now we have to classify the MNIST dataset from 0 to 9 into each digit class. So that's what, for that purpose we have done. Again, fine tuning our model. Let's see. Are you guys able to follow? Code is working. You should. Okay. Hmm. Hmm. Sub same basically this is a lab notebook, but it runs on individual PC. So yeah, our ResNet 50 model is being trained on our data set. Okay, that's good. Anyone get the values? Okay, it's training. Meanwhile, let's we move further till it's training. We will come back to transfer learning again, but our sale is running. Let's wait for a while. Okay, okay. Uh, till the model is training, you guys can have tea break, teas outside. You can have a break. It will take, I can't say, like for fine tuning, for me, it took almost 40, 30, 40 minutes. So what I'm going to do is I'm going to stop in between and moving to cluster. So, so till that you can have a break. Online guys, did anyone have any problem? No error in the code. Uh, what what error are you getting? Can you describe? Name model is not defined. हाँ हाँ वो कर okay. So you have to define model first, right? There might be some mistake while running. Once you define this CNN model class, you have to run. Here we instant initiate a model equal to simple CNN, and further we process and print our model. Then we set up training parameters, our loss and optimizer. Basically, this is our learning rate. So right now I have set for 0.001, but you can change to zero point 0.1 to point like 10 to the power minus 5 So basically what it is, the speed of changing the gradient. If you put learning rate so high, our model will run and might be trained little bit faster, but there will be some compromise within your model performance, because sometimes what happens is fine things are not taken consider, and values can be skipped. Like if you are changing the learning rate by zero point 0.1, so your gradient optimizer will shift to, suppose, from 4.5 to 4.4 to 4.2. But there might be happening that your key global minima at point 4.005, so you can miss that value and it will keep shifting between these values only. So that's why we have to change the learning rate. Is it fine? Is it working now?
अच्छा गुड मॉर्निंग ऋतुराज सर क्या होता है सर एक बार आप ओवरव्यू दे सकते हो मेरे को अभी तो क्या अभी मेरे को जाना पड़ेगा
ओके ओके
हाँ मेरे को इसको मैंने काम किया हुआ डेटा
हम्म
मैथ्स पूरी है थ्योरी मेरे को अच्छे से पता है इसमें बेसिकली मुझे ये बताना प्रैक्टिकल प्रॉब्लम्स कौन से कोडिंग
देखो
जैसे
प्रैक्टिकल
हाइपर पैरामीटर्स ट्यून करने में
exactly hyperparameter tuning is basically you have to manually select change the parameters and test whether it is improving or not. इसमें आपका लर्निंग रेट आ गया, फिर क्राइटेरियन आ गया, ग्रेडियंट डिसेंडिंग आ गया, और अगर तुम दूसरा ऑप्टिमाइजर यूज करोगे तो उसमें आपको मोमेंटम भी चेंज करना होता है। मोमेंटम भी एक पैरामीटर होता है। मोमेंटम बेसिकली स्पीड टू शिफ्ट।
जैसे लास्ट में जब स्टॉक मार्केट यूज करते हैं, वैल्यू यूज करते हैं सब, तो इन सब में भी डिसीजन में लगता है कि कौन सा।
हाँ, सॉफ्ट मैथ बेसिकली प्रोबेबिलिटीज असाइन करता है क्लासेस वाइज फीचर के बेसिस पे। एग्जैक्टली। रेलू तो एक्टिवेशन फंक्शन पास करने के लिए यूज करते हैं। लाइक जो इनपुट आया वो फंक्शन से प्रोसेस हुआ, फिर वो आगे पास करने के लिए रेलू यूज करते हैं। हाँ, आता है एग्जैक्टली। अगर तुम लीकी रेलू का फंक्शन देखोगे तो ये देखो, जब तुम्हारे इसमें नेगेटिव वैल्यूज होती है ना इनपुट में, हाँ इनपुट में, तो एग्जैक्टली वो जीरो नहीं दिखाता, वो 0.001 0.01 x दिखाता है। तो उस हिसाब से अगर तुम्हारे फंक्शन, मतलब वो प्रॉब्लम टू प्रॉब्लम स्विच करना पड़ता है। दिस इज एग्जैक्टली व्हाट हाइपर पैरामीटर ट्यूनिंग इज। हम्म हम्म we have trained a CNN model, basically 5 epochs पे ट्रेन किया है।
एक चीज हो सकती है
हम्म
कि जो मॉडल की जो कोड है,
हम्म
ये सब ऑलरेडी
बने हुए हैं।
बने
हाँ
हुए
हाँ
हैं।
हाँ, मतलब बेस्ट वे यही है कि आप ऑफिशियल डॉक्यूमेंटेशन फॉलो
कोई प्रॉब्लम होती है, you just go to official documentation और
बेसिकली उसको हमें समझने में इजी होता है। जैसे आपको कोड्स तो मिल जाएंगे, बट अगर जैसे कोई फंक्शन क्या कर रहा है ये आपको पता करना हो तो आप ऑफिशियल डॉक्यूमेंटेशन रेफर करेंगे तो वो बेटर है। हाँ,
अदरवाइज बीच का बीच में अगर
you can refer them for baseline, but if you want to go ahead, yes, क्योंकि वो तो लोग ही ब्लॉग्स लिखते हैं। हाँ, मीडियम हो गया, एनालिटिक्स विद्या भी है, और बहुत सारे W3 स्कूल से फ्री कोड कैंप है। ये सब सोर्सेस बहुत है डेटा साइंस मशीन लर्निंग। इफ यू वांट टू गो फॉर द सोर्सेस, या देयर आर लॉट्स, बट बेस्ट इज डॉक्यूमेंटेशन। हाँ, और फिर हमने बेसिकली वही ट्रेन किया, टेस्ट किया। मैंने रेगुलराइजेशन टेक्निक के बारे में बताया, ऑर्डर ऑप्टिमाइजर्स के बारे में इंट्रोड्यूस करवाया। अभी ट्रांसफर लर्निंग में मॉडल ट्रेन हो रहा है, बट इट इज गोइंग टू टेक अ लॉट ऑफ टाइम। आई एम गोइंग टू स्टॉप इट इन बिटवीन। But I what I prefer, you guys can practice this collab music. So I have mentioned some exercise for you also in the class. I have done experimentation of WNIST. You can try, give a try for CFAR 10 or other image classification task you want. हाँ, ब्रेन ट्यूमर का मैंने ही बताया था। बेसिकली मैंने, मतलब मेरा वो 4th ईयर में प्रोजेक्ट था, तो पर्सनल इंटरेस्ट। क्योंकि जो द थिंग्स आई हैव गॉन थ्रू, व्हिच आई एम गोइंग टू टेल, नॉट द थिंग्स आई डोंट नो।
ये बेसिकली जैसे कि जैसे किसी ये सारे कोर्स तो चलो आपके पास अवेलेबल है क्योंकि रेसनेट का कोड ऑलरेडी
हाँ, ये अवेलेबल है, और अभी जनरेटिव मतलब चैट जीपीटी आ गया, जेमिनी आ गया, कॉड कॉप्लिकॉट आ गया। कॉप्लिकॉट है, जानते हो? अच्छा, ओके। मतलब वही कोडिंग के लिए कॉप्लिकॉट एआई। हाँ, तो बहुत सारे एआई बन गए हैं। तो आप एक प्रॉम्प्ट डाल दीजिए, आपको कोड बना के देगा, बट आपको बेसिक फंक्शंस कौन क्या करता है ये तो पता होना चाहिए।
इन लाइब्रेरीज के पीछे तो मोस्ट ऑफ द लाइब्रेरीज आर बिल्ट अपॉन द मैथमेटिक्स
राइट।
राइट। सो जब किसी का जैसे मान लो अगर आपके पास इफ यू नीड टू कोड अ मैथमेटिकल मॉडल then what they suggest is उनके तो code already available होंगे.
नहीं,
Then I
एग्जैक्टली
need to like
exactly. देखो अभी इतना सारा डेटा अवेलेबल हो गया, बट आपको स्टिल लाइक स्पेशलाइजेशन की जरूरत पड़ती है। जैसे कोई टास्क है पर्टिकुलर, उसके लिए एक जनरलाइज मैथमेटिकल मॉड्यूल आपको कुछ आउटपुट देगा, बट आपको बेटर चाहिए तो आप थोड़े बहुत चेंजेस करोगे, तो आप उस मैथमेटिकल चेंजेस को ही कोड के फॉर्म में लिख दोगे। So basically, what tensor is? It is just like NumPy array. Data structure of Python. It deals with it. That's how it works.
there's a numpy series of
Exactly. Linear algebra ही है kind of. तो basically what it does, mathematical operations ही conduct कराते हैं। अभी हमने इतने मतलब जैसा आप देख सकते हैं कि इतने सारे इनपुट लेयर्स है, कन्वोल्यूशन लेयर्स है, हम इनपुट देते हैं, वो क्या है, इमेज पिक्सल है। बेसिकली पिक्सल डेटा वी आर गिविंग एंड इट इज कन्वोलिंग ऑन द बेसिस ऑफ matrices. Kernel is extracting features by multiplying kernels, and in next layer we are getting the same input. The input from the previous layer we process in the second layer. So that's how it is working. So if you have something different mathematical formula, so in the beginning I define this is total raw function, just to demonstrate how gradient descent works. So basically I took a value of z, and then I took another function named square. So this is how you have to define things from scratch. If you have some mathematical idea in your, you you have to put in execution.
मैंने बस basically ये करता हूँ. जैसे I'm working on the mathematical models
Hmm.
currently.
Hmm.
So these mathematical models need to be written to be already these mathematical models need to be implemented from scratch. Okay.
No, actually, Python language में mathematics, mathematica, I guess, library है. You can explore this math function. Like Python इतना डेवलप प्रोग्रामिंग लैंग्वेज है कि इसमें हर फंक्शन का एक मॉड्यूल लाइब्रेरी। नहीं, मैटलैब नहीं, पाइथन ही। सो इफ यू लर्न ओनली पाइथन ना, इसमें काफी सारे इज फाइनाइट इज इन, मतलब बेसिक से लेके एडवांस तक हर चीज बन रहा है। या
जैसे मैथमेटिकल मॉडल्स यूज करते हैं तो फिर code basically I need to write from scratch.
Hmm. So you can write just refer documentation online. You can get best line, but it's better if you develop by yourself. Hmm.
Then do you write code about any of the tasks? So do you really copy it from the internet or do you develop your own code?
Sometimes, or like if I have to refer, I need to refer. I do, or else I can. But it's not bad to.
What I do think that it's bad.
मतलब it saves time, but only do whether you should know what you are doing, what's maths behind, yeah, what's the logic behind this. So एक input कैसे process हो रहा है आपको पता है, go for it. So are you in mathematics department, applied maths or something? Okay. Okay.
Basically, I started with initially I started with the machine learning,
Hmm.
then I switched to the mathematical models. Then now I see that in future I may use deep learning and just सेशन रिज्यूम कब करें मैसेज डाल दें
रिज्यूम, हाँ हाँ हाँ, सभी आ गए आई गेस.
आगे ऐसे बोल ही देते हैं आप उसको लागू नहीं
Okay, so let's resume the session. So see, fine tuning is taking lot of time. I want you to train the model in the rest of the time because we have to move ahead. So I am interrupting the code here. I want you to give a try and train and test, and before tomorrow's session do let me know what were the result and training accuracy, testing accuracy. So further, let's come to unsupervised learning and clustering algorithms. So basically, in supervised learning, we learn, we have training data, we have testing data, we have data with data labels for training and testing as well. But while testing, we don't give data labels to our model. We use them to evaluate our model. Just That's where we get train testing accuracy, and further we can implement that trained model in another unseen data. But in unsupervised learning, you don't have data labels. So how you are going to proceed? So we will see clustering algorithms in this session. The main library here we are going to use is scikit-learn cluster. Here we have used a demonstration of k-means algorithm, but you should refer the scikit-learn library official documentation. See, here you can learn lots of different related to classification, regression, clustering. So before you can see there are lots of algorithms already developed. First they comes in mind with some mathematical modeling, then later converted into a programming. K-mean, HDB scan, hierarchical clustering. So let's explore this documentation first. So here is the overview of clustering methods. So you can see different algorithms like mini batch k-means, affinity propagation, mean shift, spectral clustering, WARD, agglomerative clustering, DV scan, HDB scan, optics, Birch, Gaussian mixture. Here, the parameters, like in the official documentation, each algorithm and its parameters they have mentioned. So, number of clusters, basically, what clustering algorithm did does is they initialize on the basis of centroid, and आपको कुछ पता नहीं है डेटा में, बस आपको ऐसा है कि ये चार चीजें एक जैसी है, बाकी चार चीजें एक जैसी है, तो इन दोनों को अलग कर दो. इसी प्रिंसिपल पे क्लस्टरिंग एल्गोरिथम काम करता है. So we learn in yesterday's lecture how this works. This is how we are going to see. And you guys should go through documentation, I will say. So you can explore the different things as well. Okay, coming to this. So what here we did is we generated 300 samples and we give four centers like here the samples are not differentiated, they are our blue points you can see, but what we are going to do is using k-means clustering we are grouping into different four different groups. So this is motive. So using scikit-learn, we import k-means library and we implement. We set clusters equal to 4, and after running, we get this is visualization again, scattering. So these are four centroids, and the clusters are developed around them. What if we set number of cluster to 3? Let's try. Will it work? Yes, it work. And you see earlier there were two portion, but when we set to 3, the yellow points are developed. Let's set to 2. Okay, so see there is something, some biasness you can see. Yellow portion is only one cluster and rest of the 3 are violet ones. So let's set back to 4 and we will move next. So yeah, these are four clusters created by k-means algorithm. Here is the theory behind this. The k-means algorithm, what it did, it assigns the point to clusters very similarly how we might assign them by eye. But they did this clustering part so quickly. So how they did it? Here is the idea behind them. The basically maths. Expectations maximization. First, the clusters are randomly associated, and then, like it assign points to nearby that cluster center, and it converted to a particular cluster. Here we have introduced some permutation and then find. So see, four clusters are there. What if we change the data? Like, okay, let's move ahead. So yeah, here we had set 6 cluster point. So we get 1 2 3 4 5 6 cluster we get in this diagram. Same 300 sample are clustered into 6 different groups. This is the magic of this algorithm. But what if the data is literally not linear? Here we get generate moon shaped data. points, and we cluster them into two groups. So here k-means clustering did not work. It basically set the points which are left to the point 0.5 are are set to violet cluster, and right to the yellow portion are set to right to the point 0.5 are set to yellow cluster. But see, these are not divided properly. This is vertically divided. So we include here spectral clustering. This is also clustering algorithm. Hmm, okay, where it is. Okay, yeah. So apart from this, I want you to give try on DBSCN clustering algorithm, hierarchical clustering. So ahead we took example for k-means on digits. So digits is also scikit-learn data set. See, here are 10 classes. Again, 0 to 9 are the samples. And total data points are 1797 with 64 dimensionality. Integers are range between 0 to 16. Okay. So yeah, we print the shape of the data set again, as we mentioned. So what we did is we divide them into 10 clusters. We set random state 0. Why we use random state? Random state is used to repeat the uh, generated results to get the same results. If you remove the random state, it will generate like clusters are in the k-means, clusters are assigned randomly. So whenever you run the code, it will generate randomly and assign. So yeah, the mo- motive is random state used to generate the results repeatedly. So here we can see the clustered our data set shape. It is quite unclear and all. 0 to 9 labels are here which are permitted, and we can fix by each learning it. So let's see the accuracy score. It's around 80% accuracy. This is the classification matrix of the true label and predicted label. In the x-axis, you can see true label, and in the y-axis, predicted labels. So this come here. It comes true positive, true negatives, false positive, and false negatives. You should know the basic idea. I guess everyone knows. Yeah. Here I have printed the accuracy score again. So here we have implemented TSNE. Anyone have any idea what TSNE is? It's uh, you can take it like it's unsupervised algorithm. Just like clustering, TSNE is also unsupervised algorithm, and it is also based, and we can see using this TSNE we get 94% accuracy score. So yeah, that's all for today's session. And I want you to go through few things. We have created a CNN model. I want you to implement that model on CFAR 10 dataset. You will get on just like we did for MNIST, you can get from PyTorch official dataset. And again, yeah, I want you to implement regularization technique and on complex architecture. Here we have implemented ResNet. You guys have to train it after the session. And apart from ResNet, you can try with VGG16 Inception v3, which is basically a Google Net model, efficient net model, exception net, dense net. There are a lot of complex trained architecture on ImageNet. You can explore these on PyTorch Hub. And yeah, for the clustering, as I said earlier, I want you to explore DBScan and agglomerative clustering. Okay, that's all for today.